All right, Kim One, so you guys have a quiz tomorrow, March 18th, over pressure conversions and Graham's Law. The quiz will be on Quest. It's 8 questions. I think it's 12 questions total because there's some multiple parts to the questions. It'll be open from 8 a.m. to 10 p.m. And that is going to be tomorrow, March 18th. So I have a practice quiz here that I'll post with the answers and this video so you guys can see what the answers are. And as you guys can see here, I've actually already started because I had some issues the first video I made. And you'll see here that I am given 875 millimeters of mercury, and I need to go to atmospheres. So remember, watch sig figs. I have 3 in the questions, so I have 3 in the answers. So 3 in the question, 3 in the answer. All right? So here I took 875 millimeters of mercury, divided by 760. How many sig figs is that? Doesn't matter. These are all infinite. These are all infinite sig figs. So the only thing that matters is what you're given. So 875 divided by 760 will get me 1.15 atmospheres. All right. Next one, kilopascals the torr. I got 738 as an answer. How did I get that? Took 98.4 kilopascals divided by 101.3 kilopascals times 760 torr. Remember, torr is the same as millimeters of mercury. And I got 738 torr. All right, so now on to pounds per square inch, also known as PSI. I'm going to go to pascals. The only way to go to pascals is to go to atmospheres first. So I'm going to divide by 14.7 psi is 1 atmosphere. And I know that 1 atmosphere is 101,300 pascals. All right, so I put that in my calculator. This cancels, 34.5. Divide by 14.7 times 101,300. And I got 2.38 times 10 to the 5th. 2.38 times 10 to the 5th, and that's pascals. If you got the extended version, that's fine. I think it was 23,800. Doesn't matter. Quest will accept any answer. So the next one, 23.4 atmospheres is how many kilopascals? This one's actually pretty straightforward. All I do is put 23.4 atmospheres, go to kilopascals by multiplying by 101.3 kilopascals is the same as 1 atmosphere. Multiply that out, and I get 2.37 times 10 to the 3rd kilopascals. Just like that. So 2.37 times 10 to the 3rd. There. Excellent, excellent, excellent. Number 2, now the Graham's Law. The question is, how much faster is hydrogen than oxygen? And we know that hydrogen is faster because hydrogen is smaller. This is smaller, and this is going to be bigger. And you also have to remember your diatomics, which means the formula for hydrogen is actually H2 and oxygen is actually O2. So please bear that in mind when you do these, is that you need to know what the formulas are. So be aware of that. So I want to know how much faster it is. So what I'm actually solving for in the Graham's Law equation, we'll start it over here. Graham's Law equation is V1 over V2 equals the square root of M2 over M1. I am solving for this right here, that ratio. I am trying to figure out how much faster it is, which means my number better be bigger than 1. If you calculate, it's 0.2 times faster. That's not faster, that's slower. So determining what's V1 and what's V2 just kind of comes down to some logic. I know this number wants to be bigger than 1, so I need to put the bigger number on top. So my M2 is going to be oxygen, and my M1 is going to be hydrogen. So where do I find the masses? Actually from the periodic table. Oxygen's is 16, but there's 2 of them, so it's going to be 32.0. So the square root of 32.0 grams per mole over M1 is going to be hydrogen, and it's going to be 2.0 grams per mole. So I divide first and take the square root. So I divide that, I end up with the square root of only 2 sig figs, be careful here, 16. And the grams per mole cancels to square root of 16. And the square root of 16 is 4.0 times faster. So 4.0 times faster. All right, so that's how you do the first type of problem. The second type of problem is you're trying to calculate an actual specific velocity, so I actually give you a velocity, it doesn't say like relative. But it's the same thing. I've given two gases, so I have oxygen, which is a diatomic again. So let's write my information over here somewhere. So my oxygen is O2, and the mass is 32.0. And methane is CH4, and the mass is 16.0. So it's exactly half the size, but not going to be half the velocity because that's pesky square root we have there. But that's okay, we can still handle it. So let's put in our equation. By the way, this is the mass, right? So what's oxygen's velocity? It's 4.61 times 10 to the fourth, right? So 4.61 times 10 to the fourth, and that is unknown. We don't know what that is for methane. It doesn't actually matter what we make velocity 1 and velocity 2 or mass 1 and mass 2 as long as it's consistent. So let's look at my equation and think before we begin. Velocity 1 over velocity 2 equals the square root of mass 2 over mass 1. I want to make this easy on myself. I want V1 to be the unknown. Think to yourself, why do I want V1 to be the unknown? If you said, because then that makes the unknown easy to deal with, it's not in the denominator, you're absolutely right. We do not want the unknown down here, because that just it's just more area for you to make a mistake in. So let's just make V1 my unknown. So if V1's my unknown, then methane over here, this is my V1, and this is going to be my mass 1, and this is going to be my mass 2, and this is going to be my velocity 2. Now we have my four variables, we just got to plug them in now. So V1, what did we say it was? It's just x over V2, which is 4.61 times 10 to the fourth. My mass 2 is 32.0. My mass 1 is 16.0. I plug this in. 32 divided by 16 is 2. Square root of 2 is like 1.44 or something like that. Watch your sig figs here. I should only have... should have 3 here. So 32 divided by 16 is going to be 2. Square root of 2 is 1.44. And 1.44, let's make sure I double check that. I'm kind of flying blind here. Square root of 2 is 1.41, sorry, 1.41. So 1.41 times 4.61 EE4. And I get 65,001, but only 3 sig figs, so 65,000 will have to do, or 6.50 times 10 to the, put the scientific notation real quick, fourth. Okay, so, and it is centimeters per second. If you check my answer key, then it's like 6.52. I think it's the way that I rounded halfway between there, so it's fine. We're dealing with Quest here, so it's fine. All right, C. So if you got 6.52, it just depends on where you rounded. I rounded mine off here. I did not round it. I don't think I rounded it there. Estimate the molar mass of a gas that is 1.2. I had 12 times, but that number is ridiculous, so don't do that. Do 1.2 times. 1.2 times slower than chlorine. Okay. Chlorine is Cl2, and the molar mass is 35.5 grams per mole. We're going on to the tens place. It's slower than chlorine. Slower equals bigger. So your answer better be bigger than 35.5. If it is not, you done goofed. And you take a look at what you've done. The only way I'm going to get a bigger number is if my mass 2 is bigger than my mass 1. So I'm going to set mass 1 as 35.5 and my mass 2 as the unknown. So my equation is velocity 1 over velocity 2 equals the square root of mass 2 over mass 1. My mass 2 is going to be 35.5. My mass 1 is going to be unknown. I'm sorry, my mass 1 is going to be 35.5. My mass 2 is going to be unknown. Velocity 1 and velocity 2, we actually know this already. It's 1.2 because it's 1.2 times slower. So I'm going to put 1.2 right there equals the square root of x, which is my mass 2, over 35.5. Make sure we get rid of the square root first. I'm going to square both sides. That gets me, with only 2 sig figs, 1.4 equals x over 35.5. 1.4 times 35.5 grams per mole is 50. So 50 decimal, don't forget your decimal because of 2 sig figs, grams per mole. Is that bigger than 35.5? Yeah, it makes sense. It makes sense. All right, that's it for the practice quiz. Once again, your guys' quiz will be up tomorrow, March the 18th, from 8 a.m. to 10 p.m. If you have any questions, please let me know, and have a good one.